Yellowstone is one of the country's most visited national parks.
Yellowstone National Park.
In Yellowstone National Park.
Yellowstone National Park. In Yellowstone National Park.
We're tracking an unusual situation tonight in Yellowstone National Park. Large numbers of animals appear to be migrating south.
Yellowstone's valleys have been emptying fast.
Picture this: thousands of elk, bison, deer, and even mountain lions streaming out of Yellowstone National Park, abandoning their lush valleys for higher ground in a mass exodus that feels almost apocalyptic. Tourists are filming, scientists are scrambling, and the internet is buzzing with questions. Is this just a seasonal migration, or are these animals sensing something catastrophic brewing beneath one of the world's most dangerous supervolcanoes? Join us as we dive deep into the mystery of Yellowstone's animal escape, explore the science behind it, and uncover what history's deadliest eruptions teach us about nature's warnings. Buckle up, this is a story you won't want to miss. In the summer of 2025, Yellowstone National Park transformed from a serene haven of geysers and wildlife into the epicenter of a chilling mystery. Thousands of animals, majestic elk, powerful bison, nimble deer, and even smaller creatures like squirrels and foxes, began fleeing the park's iconic valleys in massive, coordinated groups. They weren't wandering aimlessly. They were heading for higher ground, as if driven by an instinctual need to escape. Visitors armed with smartphones captured the surreal spectacle: herds of elk charging across meadows, bison thundering toward the hills, and even mountain lions, typically solitary, moving south in unusual numbers toward Salt Lake City, Utah. The videos spread like wildfire across social media, igniting a global question: why are Yellowstone's animals fleeing? Yellowstone isn't just a national park, it's a geological powder keg. Beneath its breathtaking landscapes lies one of the world's largest active supervolcanoes, a colossal system capable of reshaping the planet. This volcanic giant powers the park's famous geysers, hot springs, and bubbling mud pots. But it also drives constant, restless activity deep underground. The Yellowstone caldera, formed by massive eruptions over millions of years, spans roughly 30 by 45 miles. Its last major eruption, about 640,000 years ago, ejected enough ash to cover much of North America. Smaller eruptions have occurred since, and the park's geothermal features are a daily reminder that the volcano is very much alive. Recent months have brought subtle but unsettling changes. Small earthquakes, ranging from imperceptible tremors to minor jolts, have increased in frequency. While none were strong enough to trigger official alerts, they've been significant enough to catch the attention of geologists. In July 2025, a small hydrothermal explosion near Biscuit Basin sent tourists fleeing from a boardwalk, closing the area for investigation. Scientists noted that Yellowstone averages 1,500 to 2,500 earthquakes annually, often 100 to 200 per month, due to its thin crust, intense heat, and active fault lines. Most are too weak to feel, but their uptick has fueled speculation. Are these quakes a normal part of Yellowstone's restless nature, or are they a prelude to something bigger? Biologists have proposed several theories for the animal exodus. Some suggest the seismic activity disrupted traditional feeding grounds, pushing wildlife toward cooler, safer areas at higher elevations. Elk and bison, for instance, rely on the park's lush valleys for grazing, but frequent tremors could make these areas less appealing. Others hypothesize that animals are picking up on subtle environmental cues that humans can't detect. Wildlife is known to sense tiny vibrations, trace volcanic gases like sulfur dioxide, or slight temperature shifts in the ground or water. These changes, imperceptible to us, could be screaming danger to creatures with heightened instincts honed over millennia. Adding to the mystery, regular viewers of Yellowstone's live webcams reported a slow-growing bulge in parts of the park's landscape. By comparing older and newer images, some claim to see a dome-shaped rise forming over months, particularly in areas near the caldera. Geologists explain that such ground deformation could result from magma pooling deep underground, pushing the surface upward, a potential precursor to volcanic activity. Alternatively, the park's hydrothermal system, which circulates hot water through underground channels, could be building pressure, causing similar uplift. While the bulge's steady shape points more toward magma movement than hydrothermal activity, Scientists caution that it's not yet cause for alarm. Still, the idea of magma stirring beneath Yellowstone is enough to make anyone uneasy. The fear no one wants to voice is the possibility of an eruption. A small event could spew ash and lava, disrupting local ecosystems and towns. In the worst-case scenario, a supervolcanic eruption could eject enough ash to blanket continents, block sunlight, and trigger global cooling, devastating agriculture and economies for years. Even a moderate eruption could destroy wildlife habitats, damage infrastructure, and overwhelm hospitals with respiratory issues from ash inhalation. The recent closure of Biscuit Basin after the hydrothermal blast, coupled with unverified online claims of underreported quakes, including a supposed magnitude 2.4 event, has sparked rumors of officials downplaying risks to avoid panic. Scientists, however, insist that Yellowstone's activity remains within its normal range, and monitoring is more robust than ever. To understand whether Yellowstone's animal exodus is a warning, we need to look at history. Past volcanic eruptions have shown that animals often sense danger before humans. Let's travel back to 1980, to the eruption of Mount St. Helens in Washington, a disaster that reshaped our understanding of volcanic warnings. Mount St. Helens, nature's alarm bell. In early 1980, Mount St. Helens appeared tranquil, its snow-capped peak towering over lush forests and meadows where elk grazed peacefully. That calm shattered on March 20th with a magnitude 4.2 earthquake, the first in 123 years. A week later, steam and ash erupted from the summit, signaling the volcano's awakening. Daily quakes rattled the mountain, and a bulge on its north slope began growing at an alarming rate, about 5 feet per day. By mid-May, parts of the slope had risen over 450 feet, a clear sign of magma building pressure below. Locals noticed strange animal behavior. Elk and deer, typically found in high meadows during spring, were spotted in lowlands and near roads, areas they usually avoided. Birdsong vanished from groves near the volcano, while large flocks gathered in distant valleys. Woodpeckers and songbirds, common in the forested slopes, were seen farther away, as if fleeing an unseen threat. These observations weren't formal studies, but they aligned with what scientists later confirmed. Animals were responding to tremors, steam bursts, and volcanic gases like sulfur dioxide, which irritated their senses. On May 18, 1980, a magnitude 5.1 earthquake triggered the largest landslide in recorded history, causing the North Slope to collapse. The sudden release of pressure unleashed a lateral blast of hot gas, ash, and rock that obliterated 230 square miles of forest. Trees were reduced to stumps near the crater, while those farther out lay flattened, all pointing away from the volcano. Mudflows or lahars roared down rivers, destroying bridges and clogging channels. Ash darkened skies, plunging towns into midday darkness. Nearly 7,000 large animals, elk, deer, bears, and countless smaller creatures perished. The human toll was 57 lives, many caught outside evacuation zones due to the blast's unexpected reach. Damages reached $1.1 billion, with 4 billion board feet of timber lost. Remarkably, recovery began quickly. Animals that had fled early, along with gophers and amphibians that survived underground, helped repopulate the area. Lupin plants spread, enriching the soil, and elk returned to feed on new growth. By the late 1980s, the gray wasteland showed patches of green, offering scientists a rare chance to study ecosystem recovery. Mount St. Helens continued to erupt sporadically, building lava domes through 1986, and again from 2004 to 2008. These events refined monitoring tools, including GPS, seismometers, and gas detectors, and led to the creation of the Cascades Volcano Observatory. The eruption taught us that animals can confirm scientific warnings, acting as nature's early alarm system. Mount Pinatubo, a global wake-up call. In 1991, Mount Pinatubo in the Philippines delivered another stark lesson. The volcano, nestled in the Zambales Range, seemed harmless until April 2nd, when steam and ash burst from its slopes. Scientists from the Philippine Institute of Volcanology and Seismology, PHIVOLCS, and the U.S. Geological Survey quickly deployed seismometers, tilt meters, and gas sensors. Initial sulfur dioxide readings showed 500 tons per day, a sign of rising magma. Days later, emissions spiked to 5,000 tons, then dropped sharply, indicating sealed gas pathways and building pressure, a classic eruption warning. Villagers noticed animals acting strangely. Carabaos, vital to rice farming, refused to enter flooded paddies, pulling toward dry or uphill ground. Birds vanished from the volcano's slopes, gathering in distant valleys. These signs echoed the scientific data: frequent earthquakes, ground swelling, and ash plumes. By June 7th, an explosive eruption sent ash 5 miles high, forming a lava dome. Evacuations began, moving 15,000 people from Clark Air Base and expanding to 58,000 as ash columns grew. On June 15th, Pinatubo erupted catastrophically, blasting a 22-mile-high ash cloud into the stratosphere. Pyroclastic flows, scorching avalanches of ash and gas, filled valleys, while Typhoon Yunya's rains mixed with ash, collapsing thousands of buildings. Over 300 people died, mostly from roof collapses, with the toll rising to 800 due to disease and displacement. Ash damaged airports, grounded planes, and cost $100 million in aviation losses. Wildlife near the vents perished, but animals evacuated with families survived, and wild species later returned to recovering forests. Pinatubo's sulfur dioxide emissions, 17 to 20 million tons, formed a global aerosol layer, cooling the planet by ½ degree Celsius for 2 years. Lahars, triggered by monsoon rains, caused ongoing damage for years, but early warnings saved an estimated 5,000 lives and $250 million in property. The eruption set a global standard for volcano preparedness, showing that combining animal observations with scientific data can save lives. Nevado del Ruiz, a tragedy of missed warnings. The 1985 eruption of Nevado del Ruiz in Colombia is a heartbreaking counterpoint. The snow-capped volcano, looming over the town of Armero, began stirring in late summer. Small ash puffs, sulfur dioxide emissions, and earthquake swarms signaled rising magma. Farmers noticed cattle avoiding low pastures, horses shunning sulfur-tainted streams, and dogs barking at night, startled by faint tremors. These signs matched hazard maps warning of lahars, mud flows from melting summit ice that could race down valleys. On November 13th, an explosive eruption sent pyroclastic surges across the ice cap, melting vast amounts of snow. The resulting lahars roared down the Lagunillas River, reaching Armero after 11:30 p.m. Power outages and rain muffled the danger, and poor communication left residents unaware. The mud flows buried Armero, killing over 23,000 people in minutes. Livestock in lowlands perished, but animals on higher ground survived, their earlier restlessness a missed warning. The tragedy, worsened by ignored hazard maps, spurred global changes. Colombia expanded its monitoring networks, and the U.S. created the Volcano Disaster Assistance Program. Public education and clear evacuation plans became priorities, ensuring warnings reach those in harm's way. Yellowstone today. Watching and waiting. Back in Yellowstone, scientists are on high alert. Over 50 seismometers, GPS stations, satellites, and borehole strain meters track every movement. Gas sensors monitor carbon dioxide, sulfur dioxide, and hydrogen sulfide, while seismic tomography reveals a massive reservoir of partially molten rock beneath the park, fed by a deep mantle plume. This data helps predict eruptions, but the animals' behavior adds a critical layer. Their exodus aligns with increased quakes, gas vents, and ground deformation, echoing patterns seen before past eruptions. Officials insist there's no immediate threat, but monitoring teams are tracking wildlife movements alongside geological signals. The animals' instincts, combined with cutting-edge technology, form a dual warning system. If danger escalates, evacuation plans, road closures, and emergency protocols are ready to protect visitors in nearby communities. Yellowstone's animal exodus is a gripping mystery. Is it a natural quirk or a warning of something bigger? The lessons of Mount St. Helens, Pinatubo, and Nevado del Ruiz show that animals often sense danger first, but science and preparedness save lives. Subscribe to our channel for more deep dives in Earth's mysteries. Hit the bell icon to stay updated and share your thoughts in the comments. Do you think Yellowstone's animals are trying to tell us something? Let's keep exploring the truth together.